This talk is about a new project. I started this project maybe about a year ago, and it follows up on some of the things I've been doing, but I'm sort of testing ideas, and I'm going to raise a lot of questions more than I actually have answers. But I also, since this is supposed to help you teach, I have some information that's hopefully helping you with that. And so the talk is also a combination of my own research interests and what Jamie asked me to talk about, which is with the sort of the genetically engineered crops in particular. So my own research interests, and I'm just introducing this at the outset, is about how industrial agriculture and alternatives to industrial agriculture are intertwined and related. And so, for example, how industrial agriculture hinders the growth of alternatives, but also how alternatives rely on the infrastructure that's set up for industrial agriculture. And I'm also in particular interested in the role of governments in creating this complicated relation between the two. And as Meredith introduced, I'm comparing the US and Russia because, as you will see, there's a lot of interesting similarities across the two countries. So I have a first slide, and I'm just quickly going over this because this is the second day of the workshop. It might all be obvious, but I just wanted to sort of quickly say these things that I found it very rewarding to teach and research about food and agriculture for the following three reasons. First, it's relevant. We eat all the time, many times a day, and we make constantly we make choices about what we eat, and these choices reflect cultural, social, and economic relations in which we live. That leads me to the second point. Food and agriculture are related to other teaching areas. Food is therefore sort of an interesting topic if you want to teach about other things, and these are health, environment, and social movements. Those are just some things that you can teach through the concrete example of food. So, and finally, that makes food and agriculture a sort of a rewarding thing to teach and for me to research as well, because audiences are interested and engaged and it's relevant to them. So I'll move on from here, but I just wanted to emphasize that again. So what is industrial agriculture? Everybody has a vague idea, and when I started with this, I kind of thought I knew what it was, but I'm just going to give you a few concrete things that I think are the main characteristics of industrial agriculture. It aims to increase efficiency and yields. So increasing yields is really at the core of industrial agriculture, and there's various ways of doing this. Planting high yield varieties, one of them that Kathleen Morrison mentioned this morning. Another important way is economies of scale, producing more of the same in order to reduce the per unit cost. A second characteristic is the application of scientific methods, and obviously what these scientific methods are, they change all the time. You know, it used to be to have the most up-to-date combine harvester, or to have milking parlors for your cows where everything is automized. And increasingly, scientific methods means biotechnology. And we'll talk more about this later. Industrial agriculture is high input. It relies on all kinds of fertilizer, pesticides, technology that are expensive. So it's also very capital expensive most of the time. It is premised on intensive monocultures, because you can only achieve these kind of economies of scale if you produce a lot of the same kind. And just sort of a graphic example, maybe you've seen these huge harvesters. They only work if the fields are huge. They don't work if you have sort of crooked little fields on hilly countryside. A fourth characteristic is that it distances farmers from consumers. Now, farmers sell homogeneous products into commodity markets, which are then processed many, many times and sold to supermarkets. So one way of thinking about this is that the production chains from the soil to the person who eats are incredibly complex, and they can stretch across the globe or they can stretch across the country for sure. And many different actors are involved in this process. And finally, another characteristic is that industrial agriculture has led over time to the consolidation of ownership and to corporate agribusiness. This is evident in almost all sectors of agriculture. There's more big farms and that produce a larger share of all kinds of sectors. It's true for livestock. It's true for corn, soy, rice, cotton, peanuts, for sure. Those are the big grains. Now, I will be talking about genetically engineered crops, and I just want to mention that they are really a reflection of all these things. One of the chief aims of genetic engineering is to increase yields and efficiency. They are sort of what is considered by the biotech industry the cutting edge of biotechnology and scientific methods. I'm just going through this list again. They're very high input. They're using less. They're produced to use less fertilizer and pesticides, but they're high input in other ways. And in the sense of seeds need to be purchased all the time. They are talking about monocultures. They're exclusively available for monoculture. They are really only developed for the big crops. And finally, the distance between farmer and consumers, it's the same point. They're produced for the kinds of long production chains. And finally, talking about agribusiness, they are produced by a small handful of companies. We'll talk about this more later. My second slide on industrial agriculture is the role of the government or the role of the state in promoting industrial agriculture. And the point I want to make here is that this is not just a natural or more efficient way of producing food. For much of the 20th century, industrial agriculture has received all kinds of government subsidies, and this explains the dominance and how we've ended up where we are today, where much of food is produced in this way. So these are different tools that have been used over time. And subsidies are just direct payments to farmers that compensate for crop shortfalls. Credits are subsidized credits for farm machinery and for other kinds of technology that are used. Knowledge and information. These can be all kinds of things. Broadly in speaking, introducing farmers to the methods of industrial agriculture. And it's things like the public extension programs of the public universities, etc. But more and more, again, it's research in biotechnology. Another big way industrial agriculture has been supported is through export promotion. The U.S. government really actively helps all kinds of sectors to sell abroad, which food aid is sort of a separate thing, but it sort of goes into that topic as well. And finally, crop insurance. And you might have heard that the Farm Bill was passed. It's a 5-year package of legislation that was passed again last week. And it shifted a lot of the support that USDA is giving to farmers from subsidies to crop insurance. And crop insurance is basically a taxpayer-subsidized insurance policies for farmers. And there's complicated politics behind this shift from subsidies to crop insurance, and I'm sure we'll be hearing more about this. But essentially, it's a different type of subsidy for farmers. And it's huge. It's billions of dollars every year. So let me talk a little bit about the comparison between the US and Russia. And I have Russia/Soviet Union because a lot of this 20th century promotion of industrial agriculture happened during Soviet times. Now, as I mentioned, the two countries pursued remarkably similar goals for much of the 20th centuries. And in fact, the outcomes have been similar. The scale of farming, the focus on yields, and the focus on efficiency, the things that I introduced above. And these similarities are not coincidental. There's, sort of generally speaking, there's been a global trend towards these kinds of farming, but more specifically, there was knowledge transfer between the two countries for much of the Cold War. Even though the two countries are at war with each other, there have been agronomists that have gone back and forth, even under Stalin, and the exchange became more official in the 60s, from the 60s onwards. So the Soviet Union was impressed with the U.S. achievements in sort of what were called modern farming methods, and the U.S. was impressed with the scale of Russian farms, because as the state was more involved in creating these farms, they were just huge. And one of the most famous Cold War moments was when Khrushchev visited a farm in Iowa in 1959 and sort of was impressed with the corn, the way corn was produced, and went back and started a huge corn campaign in the Soviet Union, which led to a surge of corn production in the Soviet Union in the 60s. So while the goals were similar between the Soviet Union and the US for most of the 20th century, the methods were different. In the Soviet Union, there was this planned economy, and the state planning system was able to sort of allocate funds as it saw fit. And even though we wouldn't call these things market principle in general, in the US, industrial agriculture works through the market, which was not the case in the Soviet Union. So, however, so in the Soviet Union, the state was more directly involved. It allocated funds, and it made decisions for the state farms. Farms were all so-called sovkhoz or kolkhoz, which were not privately owned, they were state-owned farms, and they were large. So despite the more active intervention and sort of more direct management, the Soviet state was not as successful as the state, judging by its own criteria, judging by the criteria of industrial agriculture. There were serious shortages in the Soviet Union, and the shortages became a growing problem as the population urbanized. In the US, on the other hand, arguably industrial agriculture was too successful. While there were shortages in the Soviet Union, the US consistently overproduced. And you might have heard about that. So let me see. So the premise of my own research is that sort of regardless of the success or failure measured by its own standard, measured by the standards of industrial agriculture, the flaws of industrial agriculture became obvious in both societies around the 1980s. And alternatives started developing in both societies in response to these flaws. And these are sort of three broad type of alternatives, and as Alex mentioned, there's many different forms that alternatives can take, and I'm sort of exploring how the alternatives in the US are different from the alternatives in Russia, and how they're related to the model of industrial agriculture that was promoted by the state. So I'm just going over these as a way to then say how genetically modified food is very distant from these alternatives. Organic production is just one way of. The organic movement started as an alternative to industrial agriculture, and some people have now argued convincingly that the organic movement has been undermined by industrial agriculture, but sort of as a goal, as a social movement, it had the idea that it would promote sustainable practices with no synthetic fertilizer or pesticides. It will promote crop diversity and crop rotation that are meant to sort of restore the soil and rather than deplete it, which is the case in monocultures. Other goals of the organic movement were the preservation of family farms and the promotion of healthy food and healthy eating habits. So that's sort of one type of alternative. Another type of alternative is direct marketing, and that goes back to what I was saying about the long production chains in industrial agriculture. The idea is to bring consumers and producers closer together. And it addresses the problem that farmers face because if they sell into the undifferentiated commodity markets, they get really little. If they're producing milk or dairy, if they just sell undifferentiated fluid milk, they get very, very little, and it's very, very hard to survive. The direct marketing is a way for farmers to get more money for what they produce, and if they produce a better product, to get the reward from that directly from the consumer. There's three ways of direct marketing: is bring your products to farmers markets, organize CSAs or other types of local food initiatives. And there's also the option of on-farm value adding, which basically means, produce processed food on the farm. So produce sausage, slaughter the chickens on the farm, produce sausages, sell the sausages, make jams from fruit or yarn from wool or these kind of things. And all of these things can be sold at much higher prices than undifferentiated raw materials. And then finally, subsistence farming is a different type of alternative. It is a bigger part of the Russian food system than it is in the US. It was actually very important in the Russian economic crisis in the 90s. There are certain commodities that up to 50-60% were produced by people in their backyards. And backyards is the wrong words. They're produced on their garden plots or on their summer homes. So dacha is the Russian word for summer home, and the urban-rural geography looks very different in Russia in that many Russians have these garden plots that are located not too far from where they live, and to some extent that's was a response to the shortages that already existed in the Soviet Union. The Soviet state was very much against private production of agricultural commodities, but they had to tolerate it because people were really reliant on these kind of alternatives. And so it varies depending on the kind of product we're talking about. Subsistence production is big for potatoes, carrots, dairy, cheese, these kind of things. Now, there isn't really something quite like that in the US, partly because the American suburbs look really different than the Russian suburbs. But you might have heard about the urban gardening movement and in sort of really depressed cities in the US where the land is very cheap. If you live in Detroit and there's a vacant lot, you might start gardening as well. So these are really dynamic and growing alternatives, and there's a lot of interesting research in this. In fact, the AMS, the Agricultural Marketing Service of the USDA, has really interesting data on all these things because I think USDA is interested in these alternatives. So, for example, as of mid-2011, there were 7,000 plus farmers markets operating in the US, and that's a 17% increase from 2010. So, all the agribusiness food companies are excited about organic because it's such a growing sector compared to other sectors. But despite the fact that these are very growing and dynamic areas of food production, they're overall very, very modest compared to industrial agriculture. So organic, and here this is all organic, this is sort of what some people consider the true organic, including as well as sort of the big organic by the big growers. Organic is only 2.5 of the overall food production in the US. So to conclude this section, alternatives are evolving, and I think they're evolving in relation to the industrial agricultural system that have been so dominant for years. And so I'm switching gears a little bit to zero in on genetically engineered crops, which, as I started at the outset, are really sort of they epitomize industrial agriculture. This is sort of where industrial agriculture is going. So what are genetically engineered crops? They are plants whose DNA has been modified through genetic engineering techniques that insert or delete genes, and they're also called transgenic plants. They're generally, they're most common in crops. Corn and soy are the two big ones, but you might have heard of the flavor-saver tomato. Anybody knows the flavor-saver tomato? Which is the first actual sort of product that was sold as such in supermarkets. More recently, the biotech industry has tried to engineer livestock. Salmon and pigs are the newest frontier. Maybe Alex knows more about the pigs. And I just want to say one more thing about how this is all different and new. So the biotech industry likes to stress that, really this is no different than traditional breeding methods. And traditional breeding methods have been used for centuries, and we should all not be too concerned about this because it's no different than selective breeding. And that is technically true. The traditional breeding methods does change a plant or an animal's genetic material. And traditional breeding relies on reproduction that generates desirable traits in the animals or in the crops. At the same time, this is pretty different, I would argue. And I think it's pretty different for three reasons. Genetic engineering is much more precise. It's done by splicing a very particular gene that has a very particular outcome from one species and inserting it into another species to produce that trait in that new species that the old species wouldn't naturally exhibit. So the second big difference, so the first difference is I think it's very much more precise. It's much more about one particular trait that's created in the new species. Secondly, it inserts genes from a different organism. That wasn't possible with traditional breeding methods because you have sugar snap peas, crossed with other sugar snap peas. This is, you take the genes from a bacteria and you insert it into a salmon, or you inserted it into a corn plant. So it's genes from different organisms that are combined. And finally, a third big difference is that it's incredibly complicated and relies on very specialized technology that can only be done by very few, very well-endowed research labs. If you were breeding the sugar snap pea, that requires skill and knowledge and technology that's sort of not trivial, but anybody could do it. It didn't really require a lot of money. But this kind of genetic engineering is done in research labs that literally cost millions every year. And it's done at a few universities, but mostly in the private sectors. And only very few companies can do this kind of thing. So I think that's actually maybe the most important differences between traditional breeding methods and this kind of genetic modification. So, oops, I see I have a 1, 1, and a 3. That's supposed to be a 2 and a 3. So point 2. Point 2 and 3 are just to give you an overview of what why is this so common? What do people think are the main benefits? And 3, what people think are the main risks. So what are the benefits that proponents emphasize? It increases yields while reducing pesticide usage. So one of the most common applications of GE corn is that it breeds a plant that is resistant to glyphosate, which is also known as Roundup. So you grow a corn plant and you can spray it with very little pesticides, and the plant is resistant to this pesticide, and only the pesticide and herbicide. So only the pests and the weeds die, but your corn grows happily. Which is why you can use less of it. So it increases yields while reduces pesticides. The biotech industry also likes to emphasize that it produces new food ingredients. So you can produce corn that's has higher levels of DHA and ARA, which are fatty acids, which are considered important for people's diets. Genetic engineering also produces new flavors, colors, and consistencies, and different types of nutritional value. So you might have heard of the golden rice, which is the idea to produce a rice plant with more vitamins. And if you think this looks a little corny, the new flavors, colors, and consistency, I got that from their own website. So that's what they emphasize. Now, what are the main risks? Cross-pollination basically is the idea that you have a field of genetically engineered corn, but it exists out there in nature, and it spreads to wild population, and it spreads to other more traditional populations of corn. So that has, on one hand, in the long term, unknown environmental effects. We don't know how these plants interact with the environment, with other species, with traditional crops. And in the more short term, it has effects on organic farming, because under the USDA regulation of organic, there cannot be any genetically engineered inputs. So this has been particularly a problem for alfalfa. Alfalfa spreads very easily. The cross-pollination is practically impossible to have a GMO alfalfa in one field and not have fields around it what's the right word? Cross-pollinated, so here we go, by this GMO alfalfa. Another really interesting effect is that super pests and super weeds have evolved even in the short time that GMO crops have been around. So these are weeds that are resistant to glyphosate and Roundup, even though initially they were meant. So as the corn that's resistant, the weeds have become resistant, which has actually meant that even though initially pesticide use has dropped, farmers have to use more pesticides again, or use a combination of pesticides and herbicides to deal with these new super weeds. Another risk or drawback that people emphasize, or that opponents emphasize, is that property rights for these kinds of crops are held by large corporations, and very few of them. And if farmers, so basically that means the seeds are patented. If farmers use the seeds in ways that are not deemed appropriate or legal by these big corporations, they can be sued. And there have been many lawsuits under these kind of property rights infringements. And finally, opponents just also emphasize that there's unknown effects on the environment and on health. There's been very little evidence that these types of crops are harmful for people's health, but opponents just emphasize that we don't know. Nature has its own way of responding to interventions. So if these things haven't been around long enough to study their effects on environment and health. So genetically modified organisms in the US. This is sort of just a brief overview and a brief history. They were first regulated in the 80s under something called the Coordinated Framework for Regulation of Biotechnology, and it brings together different agencies. Now, it's pretty important that USDA is the lead agency. If a new strain of GM crops has to be approved, it's the USDA who does that. And the USDA traditionally has been very much pro-biotechnology. Which gets me to the second point. Biotechnology has received, or GM crops have received high level of government support since the 80s. In sort of 92, it was taken up as a political issue, and I have a quote from Dan Quayle, vice president at the time, that the US is a leader in biotechnology and in agriculture, and he says we want to keep it this way. And now, 20 years later, this is very much the case. They've succeeded in keeping it this way. So high levels of support over the last 30 years. New strains are approved all the time. 75 different products to date are approved. And GM crops have been hugely successful, especially with the big crops. So 93% of soy produced in the US is genetically engineered. 86% of corn produced in the US is genetically engineered, and 93% of cotton. Actually, here I had one more point about the high levels of support. A friend of mine compared support of genetic modified crops with support for organic produce in the last Farm Bill. So while the USDA does a lot to support organic and direct marketing, the support for organic is measured in millions, and the support for genetically engineered crops is measured in the billions. And she estimates that it's about 200 times the support for organic. So it's a question of magnitude. Vilsack, actually, the current agricultural secretary, said he loves organic and he loves genetically modified foods like two sons. So, equal love, but the money doesn't quite add up in that way. Okay, so here we go. Genetically modified food in Russia. Russia wants to, like in the Soviet Union, Russia wants to catch up. Very much impressed with the US leadership in this field, but it's much smaller currently. The Russian government has approved 16 strains of genetically modified crops since '96. Which is when the federal law on the regulation of genetic engineering was passed. Russia is also interested in different commodities. Corn is important, so some of the technologies and seeds are imported from the US. But Russia's agriculture, in Russia's agriculture, wheat, which I don't have on here for some reason, wheat, potatoes, and sugar beets are important. And the Russian company is currently working on genetically modified timber, as timber is one of Russia's biggest exports. So in some ways, Russia is trying to go down a similar path, and some of the similar processes are happening, but the scale is still smaller. Also, just as in the US, fears among the population exist, and just as in the US, there's no labeling requirement. I'm introducing the labeling debate. There's this quick question: should genetically modified food be labeled? Yes or no? I'm introducing the labeling debate because it's highly political at the moment. You might have heard that California is voting on this. There's a referendum in California on whether genetically modified food should be labeled. And because California is something like the 7th biggest economy in the world, just the state alone, this will have huge repercussions. But I think it's also a really nice teaching tools because it allows you to sort of summarize the main points of the proponents and opponents. So, should they be labeled? No. The reasons for no is they are not different than any other crops, and there's no scientific evidence that they're harmful to human health. The arguments for yes, they should be labeled is that consumers want them to be labeled. Sort of consistently, there have been opinion polling, and people just want to know, even if they are undecided about the health effects, even if there's no scientific evidence on their harmfulness. Another argument why they should be labeled is that even though the product is not different, they're produced very differently than conventional crops, and they do interact with their environment. We don't know all the ways they interact with the environment and health, but cross-pollination is a big issue, as I mentioned. So this is just some stats I found. 93% of the people who were interviewed by this NPR poll said they do want food to be labeled, and that applies across it. I put these numbers down because I thought it was remarkably consistent across age groups, across income classes, and across education levels. So, whether you're a poor or a rich family, whether you have lots of education or not so much, people want it to be labeled. These are sort of remarkably consistent numbers. Okay. So I guess I'm already at my concluding remarks. Here we go. What, as I mentioned at the outset, what I'm interested in is questions about the relationship between genetically modified food and alternatively produced food. So those are, again, this is sort of a reflection of the bigger question between industrial agriculture and alternatives. And so, wouldn't it be interesting if we knew? If we labeled GE food, would consumers be more willing to buy organic? And at this point, we don't know. But I think there's a consumer choice is sort of would be influenced by labeling. And so that's about the consumers. And another question is about the farmers. Would farmers rely on different farming methods if GE crops was not as heavily subsidized? So I guess I have a few more notes here about the consumers. So the awareness of GE content in food products is relatively low. Even though the desire to have them labeled is big, people don't necessarily make the connection between what the food ingredient says and this ingredient being produced through genetically modified corn. So remember this slide, here we go. 93% of soy is genetically engineered. Almost any Snicker bar or granola bar or almost any processed food is going to contain some type of soy product. And the same is true for corn. So almost every processed food contains some kind of genetically modified soy or corn. So that's why, in fact, I think the agribusiness has resisted the labeling so fiercely, because if people were aware how much of the food they eat contains genetically modified food, they would make different choices. And in terms of the farmer's decision, I think it's not particularly controversial to say that intensive monocultures displace alternatives. It's just very, very, very profitable to grow this kind of corn and soy at the moment. And at the other hand, it's very risky to transition to organic and pastured livestock. And these kind of profitable versus risky, these kind of calculations that every farmer has to make, in part that's a result of government policies that support industrial agriculture consistently in certain ways. So finally, I'm going to wrap up this section and these concluding remarks. If the point is basically, if we are committed to alternatives, we have to make sure that producers and consumers have more information about and different choices. Thank you. Oh, turns out that I did have one more slide, but all these links and resources are on the website that Jamie put together, except the last one, the Agricultural Marketing Service. I just thought of that the other day, which is a good source for farmers markets and that kind of things. And so here we go. This is the last one. Thank you.